Hello everyone, welcome to today's tutorial, and in this tutorial we're going to be looking at Python for physics, right? And in particular we'll focus on VPython. So what is VPython? Well, VPython is just a programming language and it gives you visualizations, 3D visualizations. So it combines the power of Python with visualizations to create animations that looks very beautiful and amazing. So in today's video, I'm just going to do some very basic physics, and I would combine Python programming just for you to have a feel for what Python is and how to write Python code. Okay, so let's get started. So in today's video, we're going to be modeling this pendulum, right? So you can see the pendulum right there. It's a mass attached to a spring. It's on a horizontal surface. So it's a horizontal mass on a spring. Now we're going to calculate some parameters on this spring, and we would simulate the spring. Okay, so here's some equations that I've written down. I've written equations for the positions, velocity, and so on and so forth. And the reason why I did this table, if you want the table, you can just send it in the comments. Go to the comment section and let me know, and I would send you the table. Okay, so the reason why I made this table is because these symbols, you cannot really write them in Python. You see X, V, P. You can't write these fancy symbols. I mean, you have F with an arrow on top. You cannot write them in Python. So because you cannot write these symbols in Python, you just have to define some variables. So whenever you see mass.pos, that's mass.position, that means X. Okay, so that's the reason why I drew this table, and we're going to be taking a look at it as we code. Okay, so let's get started. First, we're going to write down the equations of this spring. So you can see this spring right now, it is relaxed. It's in its relaxed state. So the length for when this spring is relaxed, we will call it L. So in its relaxed state, this system has the length L. So that's the relaxed length. But if you apply a force to the right on this spring, what would happen? Of course, it's going to stretch. So it's going to stretch, and then you would have some extension. This extension, I'm going to call it D, the displacement. D for displacement. And then you would have the length from here all the way to that extension. We'll call that length S. So we'll call it S, and it's a vector, and the magnitude of that S would be S magnitude, like that. So I believe you know all these equations. Now we can calculate some parameters on this spring, right? So we could calculate, let's say, the mass. Sorry, not the mass. The mass is of course a constant. We could calculate the force acting on the spring when we apply some force. When we stretch it, sorry. And then we can calculate the momentum, the acceleration, position, and so on and so forth. So let's say that the spring constant K is equal to 10. The spring constant is 10. The mass is 10, and that's 10 newtons per meter. That's the spring constant. And let's say the mass of that spring is 1 kilogram. 1 kilogram. And let's say the length of the spring is 1 meter. I know 1 meter is very long, but for our demonstration, we're going to use 1 meter for the length of the spring. And then we'll call the initial velocity V naught equals 0. And then the initial momentum, I'll call it P naught, that is equal to 0 as well. But basically, remember the momentum, the initial momentum is P is equal to M times V naught. And that would be 0 because V naught is 0, right? Then we can calculate S. So S is X minus X naught. And what do I mean by X minus X naught? Let's go back to the spring. The length at the start here, the position is X, and then this is X naught. So to calculate the velocity, this is X naught, I should say, and that one right there is X. So X minus X naught would give you S, the position, X minus X naught. So that's S. And this X would change. When you stretch the spring, it's going to move to the right, and then it basically just compresses and expands. And then we can calculate the magnitude of S. You know how to do that. The magnitude of S will be equal to the magnitude of X minus X naught. And the reason why we're doing this is to get rid of the negative signs. So we'll take the absolute value. So how do we calculate the force? I'm going to come here. I've got some space here. So F, the force, is equal to minus K times the displacement times the unit vector in the direction of S. And the reason why we have to take note of the unit vector is because remember the mass is changing position. It goes to the left, then it goes to the right, then it goes to the left. So you've got to keep note of the direction, and that's the reason why you have to multiply by the unit vector. Then you've got the momentum. We're updating this formula, so we update the momentum. Momentum P is equal to P naught plus F times the T. Well, if you've forgotten how to calculate that formula, remember force is the P dt, the rate of change of momentum. So if you do some integrals, you could have that dP is equal to F dt. Integrate this from P naught to P, and then integrate this from T to T naught. Right, so you would have you would have the formula up there. P equals P naught plus F dt. And then we'll update the velocity. To update the velocity, V is the is the momentum divided by the mass, because momentum, of course, is mass times velocity. And then finally, we'll update the position. Position X will be equal to X plus P over M times the T, the time step, the change in time. Now, you see these equations and you think that we'll write these equations like this in Python. No. I have defined each and every one of these variables. You can see them in the table right there. I've defined all the variables. So don't get lost when I start to write down the variables, okay? So just write in the comments, request for it, and I'll send it to you so you can also follow along. All right, so enough of the talking. Let's go write down some Python code. Okay, so to write down some Python code, all I'll do is I'll just open up a browser. I'm on Chrome. So on Chrome, I will type this trinket.io. So when you open trinket.io, you've got to sign up. Well, I've already signed up. So if you've not signed up, the first thing you do is you have to sign up. And I don't know why it's taking so long to load right now. Trinket, let me try that on a new tab. Trinket.io. Okay. So just give me a moment, please. We'll continue in the next video. I'm having some issues trying to load up Trinket.